This is Beyond the Green Screen, an Arizona's Family Originals podcast.
Hi there, I'm Royal Norman. Welcome to Beyond the Green Screen, the first Alert Forecasters podcast. And I've been looking forward to this one ever since I read this young man's paper about 3 weeks ago, even though it's about a year old or so. Christopher Callahan, postdoc up at Stanford in the Earth System Sciences Division, is joining us today. And he wrote a paper called Global Warming, Home Runs, and the Future of America's Pastime. Now, anyone that knows me and how much of a baseball nut I am knows that this is something that I'd have to talk to somebody about. So, Christopher, we welcome you to the podcast, and thank you for joining us today.
Thanks for having me.
Yeah, so here's the thing I would like to talk to our guests who are weather folks, because I'm so intrigued how they got started and what their interest was when they were a kid. Did you have weather or climate in your mind when you were a youngster? Is it something that you thought of early or came late, as it did for me?
Yeah, I was always interested in science. So science in general was always on my mind in one form or another, physics, chemistry, things like that. I was never as much of a weather nerd as some other folks. Like I know I have some colleagues who spent their childhoods looking at the clouds and doing amateur weather forecasting and things like that. I came to it via an interest in sort of climate change and the Earth system more generally. And so in college and graduate school, I got more and more progressively interested in specifically the way that climate change will affect the things that we care about.
And climate change is a real thing, is it not?
I would like to think that it is. I think our evidence suggests that it is.
Well, I ask that because, there is a constant barrage of information that will challenge that assessment. In fact, I was reading, I get the stuff, I get all the environmental stuff and I read it all. And today there was an accusation that the temperature data since the mid-1990s, 1950s has been fudged. And so climate change isn't real. When you hear stuff like that, how do you react?
You know, it's tough. I think I try to be civil as much as possible. I'm not looking to get into a fight with anyone. I think what I can say is that the best evidence that we've got is that the global temperatures are rising. And this is something that we have so many different observations of and so many different lines of evidence of at this point that if it were truly not real, the level of things that would have to be going wrong is so extreme that it just sort of beggars belief. With respect to temperature data in general, we obviously are never sure exactly what the global mean temperature is at any given time, but we have lots of weather stations around the world. We have lots of really smart people working in weather stations and doing weather forecasting, and they've told us that over the last 100 to 150 years, we can observe a pretty steady increase in the global temperature. And in general, we don't think there's too many issues with those data.
Well, I appreciate that. And in fact, I would say that an observation that I've also read from others, scientists, and that I have no way of quantifying this at all and justifying it, but it almost seems like a lot of the predictions that were made by the models in the 1990s and the early 2000s were wrong in the sense that they didn't account for enough. In other words, it seems that this thing is accelerating a little bit on us. Is that fair to say?
I would say that's a topic of really active debate right now among scientists. We actually don't quite know whether things are worse than we thought they would be. There's some evidence that, for example, sea surface temperatures are very, very warm and even warmer than we can fully account for at the moment. There's other evidence that the sort of overall trend of global warming is pretty in line with what the model suggested. But it's fair to say there is a debate among scientists, a really active one right now, about whether global warming is faster than we thought it would be. And I don't think we have the answer yet.
Now, folks, we are going to get to baseball. I promise you that. But since you mentioned the sea surface temperatures, they're amazingly high this year. And that's one of the areas of debate or of concern is how can they be this high just over a year's period of time?
It's a really important question. It's something that we're not totally sure about yet. So you all may have seen news reports. People may have read news articles about this, that over the last year or so, ocean temperatures have really skyrocketed. They're way higher than most previous record-breaking temperatures even. There's a few possible reasons for this. The first is global warming. increases in the Earth's temperature will just give us warmer ocean temperatures more generally. One potential contributor is El Nino. We are coming out of an El Nino cycle right now, which is characterized by very warm temperatures, especially in the Pacific Ocean over the winter. And the last possible contributor is actually changes in shipping. Folks may have read about this. If you're not familiar, a couple of years ago, the international organization that governs shipping regulations made a change to reduce the amount of air pollution in shipping fuels, which means that these giant container ships that crisscross the ocean, bringing us our products and our goods, are actually emitting less air pollution, which is letting more solar radiation come through the atmosphere and warm the ocean temperatures. And so ultimately, this could be a side effect of those kinds of changes. Although I will say it does seem like these ocean temperatures are even higher than can be accounted for by those factors. And so again, there's a really active debate among scientists right now about what might be contributing to them.
Yeah, it's really interesting to read about the change in the shipping and how that alone, a positive change, you would think, making the air quality better, has a weird feedback on the sea surface temperatures. That's just kind of weird, you know?
It is weird, and it's ultimately something that people have been concerned about for a while. You know, in the 1950s through the 1970s, we had a ton of air pollution in the United States and around the world. And so the United States passed things like the Clean Air Act. We cleaned up the coal plants, places around the world cleaned up the air. And we saw global warming accelerate after the 1970s into the present. And so there is a precedent for cleaning up the air having this sort of unfortunate side effect. That doesn't mean it was the wrong thing to do, but it does mean that making the air cleaner in terms of air pollution has to go hand in hand with greenhouse gas emissions reductions to make sure we don't get those side effects.
Yeah, it's very interesting feedback there for sure. All right, shall we do baseball? Why did you decide to do global warming home runs and the future of America's pastime as a paper? What drove you to that?
Thankfully, this is a little bit more lighthearted than some of the other things I get to think about. I'm a baseball fan. I grew up in Chicago, so I grew up a Chicago Cubs fan.
Cubs fan? Oh, dude, yeah. I love that. Yeah, 2016, man. You still? I mean, that was unbelievable, wasn't it?
I was, I had lucky enough to have a friend living in Wrigleyville in 2016, so I was down there.
Man, okay.
They weren't there. They were, but.
Yeah. Sorry to interrupt. All right, so, Cubs fan, go.
in between the heartbreak and the success of being a Chicago Cubs fan, we know that when the temperature is warmer, the air is less dense. All else being equal, there's less air resistance. And folks in baseball have hypothesized for a while, actually. We did not come up with this idea. Other folks came up with this idea that if the air is warmer, it's less dense, a hit baseball will fly farther. And you might actually get more home runs, if the air is warmer and therefore less dense. But we decided to actually look into the data on this and sort of take it beyond the hypothesis. One of the nice things or the bad things about being a baseball fan is that we're all nerds. We have a ton of numbers and data about the game. And so we were able to show using all of this data that on average, when temperatures are warmer, you get more and more home runs.
And you say in here 240,000 individual batted balls were put into this study. How do you even start doing that?
Well, again, this is one of those things where we are really standing on the shoulders of the other folks that have done the real work here. So I believe between 2008 and 2010, there was this StatCast system of high-speed cameras that were installed in all these MLB parks. And so we have these really high-definition, high-speed looks at every individual ball that's been hit. And so we can track the distance, the launch angle, the launch speed, and all of these things. And we can sort of systematically say, if these balls were hit on warmer days versus cooler days, what happened? And it turns out they went farther.
That's amazing. Now, when you're talking about density, you're not talking about, dew point / humidity, moisture in the atmosphere. That's a separate issue. Is that right?
Yeah. So in general, just if you think about dry air that is higher temperature is less dense on average.
Right.
Humidity is a bit of a separate issue. So yeah, we left humidity mostly to the side. We discussed it a little bit, but primarily we're thinking about mostly non-humid air.
So did you break it down into like 1 degree Fahrenheit equals how many feet extra or how many home runs extra on batted baseballs in the majors?
Yeah, so we were able to see that at least over the course of the last 70 years or so, 1 degree Fahrenheit gives us several percent more home runs per game.
Wow.
So this means, it's not the only contributor. It's a couple of percent. And so on average, though, it means that if you take all of the games in the MLB and you warm them all up by a degree or more, you're going to get several hundred more home runs per year.
So a game at Wrigley Field, our favorite ballpark, with no wind, because wind is usually a factor there. A game at Wrigley Field, all things being equal, one day it's 70 degrees, one day it's 90 degrees. The day it's 90, there's more likelihood for home runs. That's what you're saying.
Absolutely. And this is something that players and managers and coaches have an intuition for as well. News reporters were going out and asking them when our paper came out, like, do you believe this? And they pretty much all said, yeah, we know that when the temperatures rise, when the summer comes, balls just start flying out of the park. And so this is really consistent with kind of how we've all felt this to go.
Yeah. So it's sort of been observed, but your research and some others is sort of codifying that and proving that, yeah, what we think we're seeing is indeed the case.
Yeah, we think we were able to put some numbers to some sort of existing intuition or feelings that we had, which doesn't mean we came up with the idea, but it's a nice way to be able to put some numbers to it.
Were there any surprises that you saw when that you found as you were collating this data?
I think the biggest surprise for me was how different this can look in different ballparks. So purely by chance, it turns out that Wrigley Field actually has the greatest number of future projected home runs from climate change, which is primarily because most games there are played in the day.
Oh.
It has way fewer night games than most parks. And so during the hottest parts of the day in the early afternoon, those temperatures are going to be higher. And so you're going to get more of this effect. Whereas if you're in ballparks where you're playing in the evening, or if you have a dome over the park, you're going to be mostly insulated from this effect. And so it turned out to actually be pretty widely varying in different ballparks.
And so here in Phoenix, as you know, we have Chase Field, which we might have 10 to 12 to 15 games with the top open, but it's usually domed. So a domed field, obviously, I'm going to say obviously, but I might be wrong. I don't want to be, assuming it, but a domed field really doesn't come into play here, does it?
Yeah, in general, we found that this effect does not hold in dome stadiums. They're
cool.
mostly insulated from that effect of temperature.
So you also have a chart where you're sort of projecting the number of home runs going into the future, which I find is amazing. And the highest of the arcs that you have on there, I don't know if you call those predictions or whatever, says additional home runs per year by the end of this century could be 500 more home runs per year in the major leagues. That's crazy.
Yeah, it's a high number. It's several percent more per year. It would be something by the end of the century, we would be able to see it. Like that pattern will be really visible on a day-to-day basis. Now, we are lucky at the present in the sense that we don't really think that we're on track for that kind of highest worst case scenario. Like we're kind of most likely to be kind of in the middle of the road there, given our greenhouse gas emissions and things like that. Mm-hmm. And it's important to say, or at least we felt that it was important to say, that there are lots of things that MLB or other people might do to adapt to this change and potentially prevent it from happening, which might mean putting more domes on stadiums. It might mean playing games in the evening instead of the day. And so in general, we left that projection as sort of all else being equal. If these patterns continue with no other changes, yeah, we could see some pretty substantial increases.
Yeah, and the other thing that is done in some ballparks, including here at Chase, is that they keep the balls in a humidor at a certain temperature and a certain dryness or relative humidity. Now, you didn't study that, but that can impact how far a ball goes, can't it?
Yeah, absolutely. They do that at Coors Field because it's a mile above sea level, and so the air is way different there. And so, yeah, certainly if were changes to the way that MLB either manufactures the ball, they change the height of the stitches, for example, or they keep them in humidors or change the settings there. That could definitely play a role here as well.
So do you ever sit at a game now that you've done this research and one of your favorite players, this happened to be in the playoffs last year with the Diamondbacks, cracks one and you go, that's got to be out of here, and then it's caught at the track. Are there any times when you're at a ball game and you're just thinking to myself, yeah, I predicted that ball would get into the stands?
You know, a few of all four of us from the authors of the study went to a game at Fenway Park a couple of years ago, in the process of writing the paper to do some quote unquote field research, which mostly just meant us going and enjoying a Red Sox game. And there were a couple of home runs where we pointed at those and said, well, if it was cooler, probably wouldn't have gotten out of the park.
Yeah, so that's interesting, and folks can know that. The other main factors I would think are wind, which you didn't study, but wind is a big factor in home runs, yes?
Absolutely. It can totally determine it. And, you know, in many of those games where you see the ball go up and you think, oh, that's got to be out of here, and then it's caught easily, that's usually the wind kind of pushing it in. And so the wind is tough to observe. It's tough to have high quality measurements of, because it can vary even like from left field to right field. You could have opposite winds. And so in the future, that's something we need to be able to study a little bit more, but we didn't here.
Yeah, and even the configurations of ballparks, they say that Fenway's, latest rendition really sort of hurts any wind blowing out. It doesn't get to the field. So it's that kind of thing too. And again, you didn't study humidity and, water vapor, but that can have an impact too, whether the air is moist or whether the air is dry. Is that true?
Yeah, so we looked at this a little bit, not very extensively. It turns out that humidity is interesting because increases in humidity, if you hold all else equal, actually reduce the density of air because you end up replacing dry air molecules with technically lighter water vapor molecules.
Right.
Although most people, when they go outside, they feel the humidity and it feels, thick and heavy. Although, on a sort of large scale basis, more humid games would tend to be actually slightly less dense. And so this effect would kind of be the same. Although in general, we found that when you look at what is determining the density of air on a given day, temperature has a way bigger effect than humidity.
I was going to say, so the buoyancy of the air with the extra humidity, it seems like it's more than well offset by the overall density, yes?
Yeah, temperature in terms of modifying that overall density.
Okay, well, that's cool. Hey, Christopher, I just got to tell you what, I enjoyed reading this. Global warming, home runs, and the future of America's pastime. I know we had to talk about some other climate stuff, but I appreciate that because you've got such an expertise. I would like to ask you one more question because we're talking about how we're doing El Nino into La Nina. We've got the high sea surface temperatures. We've got some 90-day outlooks into, we have our Arizona monsoon, and we're a little bit concerned that we could have another record heat year in Arizona like we did last summer. And we had one in 2020, then we had one last summer, 2023, and we're sort of looking at that again, down the barrel of the gun saying, oh no, is this going to happen again? Now, I know there's no way you can say that, but do the current trends, they seem to be bearing out a real warm period for the western third of the country and a pretty dry one too, I would say.
As far as I know, I think that's the case. I believe there was a projection released a couple of days ago by either the National Oceanic Atmospheric Administration or another government agency with their sort of summer outlook. And they projected a really hot and potentially record-breaking year this year. Certainly, it's possible.
And of course, that would not be good for natural fires and wildfires, et cetera. All right, Christopher, I picked your brain enough today. I appreciate you. I love this study about baseball. Next time you do a study about baseball, make sure you email me so that I can read it first and not get it a year later, because I really enjoyed it and I enjoyed the topic. And thank you for being with us today.
Thanks so much for having me. This was great.
This is Beyond the Green Screen, an Arizona's Family Originals podcast.